Alright, we're back in Houdini, and what I did meanwhile was upgrade to Houdini 15.5. And as soon as I opened my project, I got this warning message here that there's something wrong in my VDB Advect SDF node. And when I dove into the solver and looked at the VDB Advect SDF, I discovered it had some new advection schemes, and some old ones were gone. And I was quite pleased with that, because what this actually is it makes the solver run more reliably. So previously you at sometimes ran into cases where the volume suddenly disappeared or your simulation broke, and I haven't discovered that with this updated VDB Advect SDF node yet. So quite positive, surprised on that. Okay, now a quick disclaimer. So let's just clean this up. That's inside of our solver, and this is our setup. Quick disclaimer, what I'm about to do now, I didn't come up with that. It was an idea, I think, originally by Etu on the oddforce.net forums. And if you don't know oddforce.net, you should definitely hang out there. It is the place where you get advanced Houdini techniques and advanced Houdini questions answered. And one of the most amazing guys there is a guy called Etu, who's done a lot of amazing setups, a lot of amazing technique. And he came up with the idea of, instead of advecting this volume just purely based on the gradient, so basically kind of along its normals, he used the curl noise to advect it, which yields very organic, like flowing lava or just like hardened lava shapes. So let's build that. And in order to build it, I need to take care of some things. First, I just would like to get rid of those VDB smooth nodes here, because we want a non-smoothed vector field and a non-smoothed geometry. And what I'm also going to do here in the VDB Advect SDF node is, under here the spatial renormalization scheme, I'm going to set that the first order biased gradient. And what that is, it's a bit more unprecise, but it's a quicker algorithm, so simulation times will get better. I'm going to lower the renormalization steps as well, but before we do all the calculations, I'm going to add a VDB renormalize node. So that makes sure we have a proper volume here before we go into all the calculations. Next thing is I want to add some stuff here in the volume VOP, where I do the calculation of mixing or scaling the advection direction by the curvature. I'm just going to dive in here, and one thing I'd like to do is drop down a normalize node and set this to 3D vector, and make sure that my gradient is normalized so that all the vectors in it have a length of 1. Good. Let's go up to the geo level again, and it's time for us to build a curl noise field. And one quick hack to build one is with the fluid source node. And what that wants as an input is a geometry. So a geometry that has the shape of the volume, and we're going to get that by the bound, not bound, but bound node, exactly. And this is going to give me the boundary of an input geometry, so it's going to give me that. And I want the volume to be a bit bigger than that, so it has some space on the outside as well. So what I'm going to do in here is I will give it some padding. Just like that, 2 units around it. Just ghosted out of the solver. Perfect. Okay, so now I have this box, and I'm going to turn that into a volume with the fluid source node. And the fluid source node is there to create different things. On the one hand, it is going to create a scalar volume, which we just don't need in our case. So let's just clear that out. What we would like to have is a velocity volume here. And what we like our velocity volume to have first is it should have a size that equals the voxel size on our VDB from polygon node. So the way I'm going to take care of that is just by going in here, highlighting the voxel size, right-clicking on it, and say copy parameter. I'm going to dive into the fluid source, highlight the division size, and say delete channels first, then highlight that again, delete that, right-click into it, and say paste copied relative reference. So now I can see I have the same voxel size in here as in here, and as soon as I change that here, it also changes in here. Super. Good. Let's just leave it like that. Okay, the thing we need to do now is add curl noise to our velocity volume. A velocity volume, by the way, is just a volume which stores vectors on each voxel. So it just stores a direction and a magnitude. And we can add curl noise to that by the curl noise tab and just switch on add curl noise, switch off add animate. I just want to have a static curl noise, and I will just increase the swirl size a tiny bit. And as you can see by those beautiful streamers we have now, this is just a visualization slice through the volume, but the whole volume is now filled with this curl noise. And there are some details which cost me quite some time to find out. And without adjusting these details, the setup won't work. I'm not really sure why, so if any one of you has an idea why that is, please let me know. If anyone of you has a better way of creating this curl noise volume, a more quicker, straightforward way, please let me know. I'd be very interested to hear from you. Okay, what we need to do in order for this to work is to go to the container settings and say initialize velocity. This is one thing we need to do, and in the velocity volumes tab we need to set visualization to smoke. Otherwise it would not work for my case. I don't know why. It was just like that. So what I'd like to do now is turn this volume, which when you middle click on it you can see that it's actually not a single volume with vectors, but actually 3 individual volumes, and each of those volumes just stores one component of the vector. And I want to turn this volume into just one VDB that stores vectors instead of individual components. And the way I'm going to do that is with 2 nodes. One is a VDB convert, and the other one is the VDB vector merge. So this converts the volume to a VDB, and this merges those 3 individual volumes into a single vector volume. Okay. Only thing I need to take care of is just set the naming convention right so that it takes any component of the velocity. Again, the name is specified here. That's just default name called vel for velocity. And with this expression, I'll just make sure that it regards anything named velocity, any component of that. And I want to convert it to a VDB. Now, when I hover over it, perfect. It converted the volume to 3 VDBs, 1 for each component. And now this node, I can leave that on standard settings. Gonna highlight that. And now I see I have just one volume of a type vector. Perfect. I think it's time to save that. So let's just say this. Awesome. And now that we have our VDB containing a curl noise, I'm just gonna pipe that into the solver, highlight the solver, dive into it. What I want to do is, it's coming in with input 2 here, and I want to regard this curl noise here in our calculations, which actually builds the vector field for the advection node. So just pipe that in to the 3rd input here, dive into the node. The first thing I want to do is import the vector from the curl noise, and it should be on the current position. I'm going to do that with a volume sample vector node. So that just samples a vector out of a volume, and I'm going to give it, this is the input number 3, and it should sample the input number 3, and it should sample it at the current position, at the current voxel position. What I'd like to do now is, again, same with the gradient, normalize that, so make sure that every vector has a length of 1. Wire that up, and I'm going to add another ramp node here, just to make this a bit more clear. Let's put it like that. Nope, not this ramp node, but this ramp node. I'm gonna set it to, it should be a spline ramp. Let me check that. Where the hell did that go? Okay, that was kind of annoying. As with every new version of Houdini, you have to figure out stuff. And the things I have to do when I add a another ramp node is make sure to, of course, wire it up correctly, and then call it something different than the first ramp that I have. So let's call this ramp curl, and let's go up a step and check, and yes, I have an interface here. Super. Dive in here again and set it to a spline ramp and use the output of that node to drive another multiplication node, which takes the normalized vector and the scaling factor. And the thing I'd like to finally do is add those two vectors, one coming from the gradient, so pointing outwards, and one coming from the curl noise. So that should drive our advection. Okay, let me go over this again. Let's just check. Bringing the gradient, normalizing it, multiplying it by the curvature, which I ramped. Let's call this gradient. And I'm bringing in my curl noise, normalizing it and multiplying it by this ramp, then adding both and exporting. Super. Okay. Let's see how that works. Not really the way I imagined. Okay, let's check. Now I'm going to the solver, and of course, as you can see here, my parameter ramp is set to ramp from 0 to 0. Let's try this again and bring in a bit more of the curl noise. Let's hit simulate again. Okay, that's a bit better, because as you can see, now we haven't got this symmetric look, but the voxels are being pushed around by the curl noise. Stop that. Looks a bit disgusting, a bit like something organic, in the best case like a fungus, but or a mushroom or some weird kind of organic growth thingy. Let's not think too much about it, but that was basically the look that I was aiming for. So a bit of fiddling around, and as you can see, building a certain setup in Houdini is just only one part. It's debugging it, which can also take quite a lot of time. The major parameters that you can tweak in this setup in order to be able to reach different looks is, on the one hand, in here, those two parameter ramps. On the other hand, in the fluid source, all the curl noise parameters, which drive the curl noise. And also there is one thing that I'd like to mention, and that we should definitely do before I say goodbye, is dive into the solver and go into the volume bop again. And with the curvature that's coming in here, we should remap that, because curvature does not always go from 1 to 0, but can also be higher or lower. And in our case, what I found useful is dropping down a fit range node here and just promoting the minimum and maximum parameter. So I can set those in the user face one level up higher, and I'm just gonna add that here. Copy it again. No, I don't need a copy of that because I can just wire it up like that. And what I can do now is, let me check. Yeah, is go one level higher. And in here, I don't only have those two gradients, but also these two parameters which remap the basic curvature. And just by trial and error, I found out that a minimum value of 1 and a maximum value of 7 will yield nice results. Exactly, so growth is now a bit more restrained. That's it for Advection. Again, this technique is borrowed, inspired by the awesome work of Etu on the Oddforce forum. You should definitely join the Oddforce community. Very helpful community, very advanced community, so if you have any in-depth questions, this is the right place to ask them. Aside from the side effects forums, of course. So I hope you had fun with this. again, if you create any artworks using any of the techniques here, be very intrigued to see that stuff. So please just write a message, drop a line, and cheers and goodbye.